Okay, so today's notes are going to be on solving inequalities. So our content objective is going to be to solve and graph inequalities and compound inequalities. And our language objective is going to be to use the correct technical vocabulary when describing and explaining the process of solving inequalities. I'm going to jump right into the notes, but if you need to pause and write down these objectives, please do so. So we're going to start just by a quick review of what writing and graphing inequalities looks like. So the first thing we have is an inequality. Or we're going to make a table, sorry. So we're going to have the inequality here, and then we're going to next have a word sentence. So you know how to say the math sentence. And then last but not least, we will have a graph with a number line. So first thing we're going to talk about is x is greater than 4. So as I just said, that is spoken as x is greater than 4. And our graph, I'm going to start at -1. So -1, 0, 1, 2, 3, 4, 5, 6. And just so you can see this, I'm going to use red. But 1 is greater than 4. I'm going to have an open circle, and it would go that way. So that is how I would graph that inequality. I'd have an open circle going to the right, so in the positive direction. The next one is going to be x is greater than or equal to 4. So again, this is pronounced x is greater, or spoken as greater than or equal to 4. And again, I'm going to draw a similar number line, starting with -1, 0. And this time, since it's including that number, I would have a closed circle going to the left. So if it does not include it, you leave it as an open circle. If you do include it, it will be a closed circle. And now we're going to talk about the less than. So then x is less than 4. So that symbol will be read as x is less than 4. Draw my number line. -1, 0, 1, 2, 3, 4, 5, 6. And since it is less than but not equal to, I will have an open circle going to the left. So that is how I would graph x is less than 4. And last but not least, x is less than or equal to 4. X is less than or equal to 4. I'm sure you guys have learned different ways of remembering which way it opens or closes when it's greater than or less than. So whatever works for you is great. Just make sure you will remember. And again, this one is going to have a closed circle on 4 and point to the left since it is less than, but that is how we would graph and say each of those inequalities. So now we're going to talk about solving them more or less. So the key point about solving them, I'll write this here. Our key point about solving inequalities is it's just like solving regular algebraic equations, or it is very similar to solving algebraic equations. Except, and you guys probably have heard this before, when you multiply or divide by a negative number, you must switch the sign. Sorry, you must switch the inequality. The direction of the inequality. Great. So why is this the case, you may ask? And I think for me, this actually makes a lot of sense, this little proof that they've included in your book. But it's basically showing that if we start with A, it's greater than B. If I multiplied both sides by -1, they would both become negative, right? Another way I could make them both negative is by subtracting, we'll start with B, from both sides. So if I subtract B, it's going to cancel on this side. I'm left with A minus B is greater than 0. And then I subtract A, because that will make A negative on the other side. And I get negative B is greater than negative A. And if you look, we started, like we did, if we followed our solving steps, we did not actually change the value of this statement in any way. All we did was move things around, and we can see that if we move things around, we end up with negatives on the other side. The sign is switched. So if I make both of these negative, what would actually be true is the sign would be, in this case, if we rewrote it with A first again, since if we left A on that side, this is how this statement would be rewritten. So ultimately, if you move them all, basically if you're making something negative, you have to switch the sign, because if you had moved them not through multiplication or division, but through actually moving the whole thing from one side to another, you would end up with them on opposite sides of the inequality. So the last thing I did was rewrite with A on the left. I can explain that in more detail if that's helpful for anyone, but just ask me during class. All right, so the next thing I want to do, apologies for the red marker showing through. I will avoid that. Actually, I'll just use a new page if that's easier for people to see. So the next thing I want to talk about is compound inequalities. I'm not going to show you an example of solving a normal inequality because I think you guys can do it and we can practice it together in class. So compound inequalities, just so you have a definition, are inequalities, or two inequalities joined by the words and or. So we're going to do an example of each of those, or solving with each of those. So our first example will be solving and inequalities. And for this, I want us to figure out what is the solution of 7 is less than 2x plus 1 and 3x is less than or equal to 18. So we'll do our 2-column notes with our steps. First thing I want to do is solve each inequality separately. So I have 7 is less than 2x plus 1. I'm going to do these next to each other, side by side, so I'm going to leave a little space for each, just for the sake of space. But here I would subtract 1, and I'd get 6 is less than 2x, and then I divide by 2, and I get 3 is less than x. So there's one of my solutions. If I solve my other inequality, I have 3x is less than or equal to 18. I divide both sides by 3, and I get x is less than or equal to 6. So now I've solved each inequality separately, and I'm going to graph each solution separately. So step 2, I'm going to graph each solution separately. And ultimately, you will be able to skip step 2, but for the sake of understanding the process and seeing what I'm doing, I'm going to have us do this for now. So -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, so I went to 8. So just to graph them each separately, I'm going to do this section in red. So I know for that inequality, x is greater than 3. So if I'm going to leave some space so I can include all 3 inequalities without writing over each other, but I know since it's greater, or since x is greater than 3, it's going to go in this direction towards the positives, and since it's not equal to, I leave an open circle. The next one I have is going to be x is less than or equal to 6. So I'll do this one in green. So again, I'm starting at 6. I have a closed circle because it's equal to, and since it's less than, I'm going to the left. So it would be like that. My solution set I get by where these overlap. So if I see here, this is where these overlap. I'm going to do the solution in purple, which is going to have a closed circle there, an open circle on 3, and it will connect through there. So it is that little section on our graph that is my solution. So step 3 is going to be to combine into one inequality. And this is called an and inequality because it is between these two. So if my solution is between two numbers, if it's sandwiched, I can then write it as a sandwich inequality. Or it's not a technical term, but that's what I call it. So I would keep x in the middle, and I'd have the lowest number to the left. I know x is greater than 3, but then x is, again, less than 6. So my solution, I can combine an inequality. Again, when you have a solution set that you can write as a compound inequality, I call this, again, a sandwich inequality. The lowest number has to go on the left, the largest number has to go on the right, and the numbers always need to point to the left because it's lowest to highest. So that would be our solution for the and inequality. We're going to do an example of a or inequality. And that will be our last thing for today. So similarly, I'm going to ask us, what is the solution? Of 7 plus k is greater than or equal to 6, or 8 plus k is less than 3. So again, the first step is going to be the exact same. I'm going to solve each inequality separately. So we'll start with 7 plus k is greater than or equal to 6 here. I'll draw a line so I have room for my other one. I'm going to subtract 7 from both sides, and I get k is greater than or equal to -1. On the other side, I have 8 plus k is less than 3. I'm going to subtract 8 from both sides, and I get k is less than -5. So now I'm again going to graph each inequality separately, same second step. And again, in time you'll be able to skip this step, but to show what I'm talking about, we will do this for now. So I know these are mostly in the negative, so I'm going to lean heavily on the negative side and start with -7, -6, -5, -4, -3, -2, -1, 0, 1. All right. So I'll do my first one again in red. So k is greater than or equal to -1. I'm going to have a closed circle, and it's greater, so it's going to the right. For my second inequality, I will do that in green. It's going to be an open circle at -5, and this time it's going to the left because it's less than. So my solution set, if you notice, is still going to be going in those two directions. It's not sandwiched as our and inequality was, it's in opposite directions. So it's this direction or the other direction. So my solution set, which I will keep in purple, is going to be this. And since they are not combined with an and, they are an or. I will have to write my final solution as two separate inequalities. So I'm going to emphasize this. If it's an or inequality, they must be written separately. So my solution, I choose to write the most negative one first. So I'd write k is less than 5 or k is greater than or equal to -1. And this would be my solution set. So again, since they are going in opposite directions, you cannot combine them into one inequality. All right, make sure you write down any questions, comments, or concerns, and we can go over them in class.